Today we will start with a new type of cryptography system, that is substitution cipher. Substitution cipher first of all we will recollect the cryptography system. As we know, it is equal to PCKED, where P is the set of plain text, C is the set of cipher text, K is key space, E is the encryption function set, and D is the decryption function set. And in substitution cipher, we will use permutations. But we will use permutations. From E, we have EPX is equal to pi x and its inverse, that is dky is equal to pi inverse y. Here we use P equal to C equal to Z26. And K is the key, and E and D are encryption and decryption functions. In substitution cipher, we will use, instead of this 26 characters, we will use the 26 alphabets A, B, C, D, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Instead of this Z26, we will actually use this alphabet, and the lowercase will use for plain text and uppercase we will use for cipher text. We will permute this alphabets. For example, a particular type of permutation is A is going to X, B is going to N, Y, A, H, P, O, G, Z, Q, W, B, T, S, F, L, R, C, V, M, U, E, K, J, D, I. This is one sort of permutation. This ABCD is permuting to these sets. In the order, A is going to X, B is going to N, and C goes to Y, etc. Therefore, this E pi will take A to X, B to Y, N, C to Y, and so on, and D pi will be the reverse one. Here A is mapping to D, A is mapping to D, B somewhere here, B is mapping to L, permuted to L, and the C is going to R, and so on. Therefore, this is among one permutation. E pi is going like this and the inverse D pi going like this. Using this permutation, we have, therefore, In this problem, PEKED, this K is actually permuting this 26 alphabets. Permutation will consisting of 26 factorial keys. Therefore, here somewhat key size is somewhat large. That is, it will be like this. It is approximately equal to 4 into 10 raised to 26. A huge key size. This key size is very large. Therefore, this നമ്മുടെ ഈ substitution cipher കുറച്ചും കൂടിയും സെക്യൂർഡ് ആണ്. കാരണം കീ സൈസ് 4 into 10 raised to 26 നമ്പർ വരും. അപ്പോൾ അതുകൊണ്ട് ഈ ക്രിപ്റ്റോ സിസ്റ്റം കുറച്ചും കൂടിയും സെക്യൂർഡ് ആണ്. പക്ഷെ വേറെ മെത്തേഡ് ഉപയോഗിച്ചിട്ട് ഇത് നമ്മൾ പൊളിക്കും. അത് വേറെ കാര്യം, സെക്യൂരിറ്റി കളയാൻ പറ്റും നമുക്ക്. പക്ഷെ നമ്മൾ നേരത്തെ ഉണ്ടായിരുന്ന ഷിഫ്റ്റ് സൈഫറിൽ ആകെ 26 കീ ഉണ്ടായിരുന്നുള്ളൂ. കാരണം ആൽഫബറ്റ്സ് 26. ഇവിടെ വരുമ്പോൾ അത് 4 times 10 raised to 26 വരെ നമുക്ക് കീസ് വരും. അപ്പോൾ അതുകൊണ്ട് കുറേയും കൂടിയും സെക്യൂർഡ് ആണ് ഈ സിസ്റ്റം എന്ന് വേണമെങ്കിൽ പറയാം. ഇതിൻ്റെ ഒരു എക്സാമ്പിളായിട്ട് സാറ് പറയാൻ ഉദ്ദേശിക്കുന്നത് നമ്മുടെ സബ്സ്റ്റിറ്റ്യൂഷൻ സൈഫറിൻ്റെ എക്സാമ്പിൾ. സപ്പോസ് യു ആർ ഹാവിങ് a statement like this: decrypt the following. Our encryption function or ciphertext is encrypted ciphertext MGZVYZLGH CMH JMYXSS FMN HAH YCDLM. This is our ciphertext. We have to change it into plain text. For we will use the following permutation. Here M is going to T, G is going to H, then Z is going to I, V is going to S, then Y goes to C, then Z, I, then L is going to P, then G goes to H, G goes to H, then H goes to E, and C goes to R, M, T, then H again. H goes to E, J goes to X, then M goes to T, Y goes to C, X goes to A, S goes to N, F goes to O, then M, T, N, N goes to B, H, H goes to E, A goes to D, again H, E, Y goes to C, C goes to R, D goes to Y, L goes to L goes to P, and M goes to T. You can note that this plain text will be like this. This cipher text cannot be decrypted. Cannot be decrypted. Therefore, any encryption function can be decrypted like this. There are so many possibilities, that is, this key space will consist of 26 factorial keys. This is our substitution cipher. Please cut it. Yes. Now we will deal with another cryptography, that is another cipher, Affine cipher. Affine cipher. This is the third cipher we have, Affine cipher. As in the case of crypto system, here we will take plain text, cipher text, as Z26 itself, Z26 itself, and key, the key system will be set of all ordered pair AB belongs to Z26 cross Z26, where such that GCD of A26 equal to 1. This is a particular type of key. Key is equal to set of all AB, where both A and B are lying in Z26, such that GCD of A26 equal to 1, that is, A and 26 must be relatively prime. And for any K equal to AB, we define EK of X as is equal to AX plus B mod 26. AX plus B mod 26. That is, AX plus B is a linear function, mod 26, and the decryption function dk of y equal to y minus b into A inverse, or A inverse into y minus b mod 26. Okay, this is the crypto system Affine cipher. P is P and the cipher texts are the same, that is Z26. Key is equal to the set of all ordered pair AB with the A26 relatively prime. And for any key from K, from the script K is equal to AB, we will encrypt like this: EK of X is equal to AX plus B mod 26 and dk of Y equal to A inverse into y minus b mod 26 or y minus b into A inverse mod 26. Now, in order to go in detail, we want some preliminaries. Preliminary എന്താണെന്ന് വെച്ചിട്ടുണ്ടെങ്കിൽ നമ്മൾ കോൺഗ്രുവൻസ് റിലേഷൻ പഠിച്ചിട്ടുണ്ട്. കോൺഗ്രുവൻസ് റിലേഷനിൽ നമുക്കറിയാം AX equal to B, AX congruent to B mod M possess unique solution if A and M are relatively prime. AM must be equal to 1. GCD of AM must be equal to 1. നമ്മൾ സാധാരണ GCD എന്ന് പ്രത്യേകം എഴുതാറില്ല. AM ഓർഡർഡ് പെയർ AM എന്ന് എഴുതിയിട്ടുണ്ടെങ്കിൽ അത് GCD of A and M must be equal to 1. എന്നാൽ മാത്രമേ AX equal to B mod M AX equal to B mod M possess unique solution in ZM. ZM consisting of the set 0, 1, 2, 3, etc. M minus 1. As in the case of ZM, set 26, that you know, that is 0, 1, 2, 3, etc. 26 minus 1, that is 25. Here general ring, that is ZM, consisting of 0, 1, 2, 3, etc. M minus 1. And in this ZM, the congruence AX is congruent to B mod M possess unique solution only when A and M are relatively prime. അതിൽ വളരെ പ്രിസൈസ് ആയിട്ടുള്ള ഒരു പ്രോപ്പർട്ടി എന്താ വെച്ചാൽ, if M happen to be a prime number, if M equal to P prime number, then we have ZP is a field, finite field, and it is having elements like this 0, 1, 2, 3, etc. P minus 1. Okay. As you know, in AX equal to congruent to B mod M, in order to solve or to find the value of X here, we have to multiply with the A inverse both sides. That is, A inverse is 1. That is, X is congruent to A inverse B mod M. That will be the solution, provided the inverse of A must exist. Here, inverse will exist only when AM equal to 1. Okay, the first theorem is like this. This will possess unique solution. A and M must be relatively prime. And number of elements prime to M, that is due to an mathematician Euler phi function phi of M. We want one more result. One more result for this cipher. The result says that if M equal to, M is an element of ZM, M equal to the product of primes pi pi raised to ei, I is equal to some 1 to n. That is, any composite number can be written as product of primes. As an example, we can write 60 can be written as 2 into 30, that is equal to 2 into 2 into 15, which is equal to 2 into 2 into 3 into 5, that is equal to 2 square into 3 into 5. This is the prime factorization of 60. Therefore, this 60 can be written as pi I is equal to 1 to 3 pi raised to ei, where p1 equal to 2, p2 equal to 3, p3 equal to 5, and E1 equal to 2, E2 equal to 1, E3 equal to 1. These two ones are the powers of 3 and 5. 1 and 5. Therefore, m can be written as pi, if m can be written as pi I equal to 1 to n pi raised to ei, then phi m, the number of primes less than or equal to m, relatively prime numbers, is equal to pi I is equal to 1 to n pi raised to ei minus pi raised to ei minus 1. In the case of 60, phi 60 equal to, we have pi I equal to 1 to 3 pi raised to ei minus pi raised to ei minus 1, which is equal to power, which is equal to the first one, P1 is 2 to the power 2 minus 2 to the power 1 into 2 minus 1, that is 1. Next is 3 to the power 1 minus 3 to the power 0 into 5 to the power 1 minus 5 to the power 0, which is equal to 4 minus 2 into 3 minus 1 into 5 minus 1, which is equal to 2 into 2 into 4, 16. Okay, that is an example here. Is 560 equal to 16. Now, we want one more here. Yes, we say that A dash is the inverse of E if A dash equal to A dash A is congruent to 1 mod M. Because this A dash is known as the inverse of A. Usually it is denoted by this. If it exists, A dash is denoted by A power minus 1. That is inverse of A. Here in Z26, we have the numbers which are prime to 26 are 1, 2, sorry, not 2, 2 is a factor of 26, 1, 2, then 3, 5, 7, 9, 11, not 13 because 13 into 2 is 26, 15, 17, 19, 21, 23 and 25. These are all numbers because this 1 comma 26 GCD equal to 1, 2, there won't be 2. 226 is 2 because 226 is 2, not 1. Therefore, it is not in the list. That is 1, 3, 5, 7, 11, 15 and so on up to 25. Totally we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 members in Z26 are relatively prime to 26. Therefore, we are seeking of the inverse of these 12 members. One is having inverse 1 itself, because 1 into 1 is 1, mod 26 is 1, because the definition of inverse is like this: A inverse is equal to A inverse A, that is congruent to 1 mod 26. Here 1 is the inverse of 1, therefore 1 into 1, 1 is congruent to 1 mod 26. Which is correct, because 1 minus 1 is divisible by 26, that is 0 is divisible by 26. Therefore, inverse of 1 is 1, inverse of 3 is 9. The reason is that this into inverse 9, that is 3 into 9, 27. 27 mod 26 is 1. 5 is having inverse 21. Multiply 5 with the 21, we will get 105. If it is 104, it will be a multiple of 26. Therefore, remaining 1. Therefore, inverse, that is 29 into 21 is congruent to 1 mod 26. Therefore, 5 into 21. Therefore, 21 is the inverse of 5. Conversely, 5 is the inverse of 21. Next, 7 having inverse 15, 9, 3, because 9 into 3, 27. Then 11, 19, 7, 23, 11, 5. 21 is having 5, 20, 17, and 25 is having 25 as inverse. Therefore, these are all inverses. One is having inverse, self-inverse, that is 1, 1, 3, 9, 9, 3, 5, 21, 21, 5, 7, 15, 15, 7, 9, 3, already said, 11, 19, 19, 11, and so on. These are the inverse. Therefore, only this 12 members of Z26 having inverse. Okay. Therefore, this key consisting of set of all Z26 into Z26 such that A Z26 is equal to 1. Here in EK, we are considering both A and B. Therefore, actually we have 26 into 26. A runs over Z26. B also runs over Z26. Therefore, totally we have 26 into 26 members. But there is a reservation here. Only 12 members is having inverse. Therefore, the number of keys reduces to 26 into 12. 26 into 12. Yes. 26 into 12, 260 plus 2, 3 not, do it now. Yes. Totally we have 312 keys. 312 keys. This is not much large. The K consisting of 312 keys only. As an example for this affine cipher, suppose K equal to, there are so many possibilities for K. I will choose this K A B instead of AB. I will choose 7, 3. Then EK of X is equal to 7x plus 3. And dk of y equal to A inverse y minus b, that is equal to, from here it is 7 inverse into y minus 3. 7 inverse into y minus 3. But from that list we have 7 inverse is 15. 15 into y minus 3, which is equal to 15y minus 45. That is 15y minus, after division by 26, we will get 45 becomes 19. Mod 26 will be 19. 15y minus 19. Now, dk of ek of x, dk of ek of x is equal to dk of ek of x, you know, ax plus b, that is 7x plus 3. Then dk is nothing but, you know, this 15y minus 19, that is 15 into, instead of y we have 7x plus 3 minus 19, that is equal to 15 into 7, 105x plus 45 minus 19, which is equal to, as you know, 105 mod 26 is 1, that is 1x plus, here it is, on subtraction we have 26. 26 we know, 26 mod 26 is 0, therefore it is equal to reduced to x. That is, applying dk and ek simultaneously, we will get the x itself, that is identity mapping, dk, ek cancelled each other and we will get x itself. As a simple example, we will encrypt my name itself. How it will be? Joju will be encrypted. First we will change it into alphabets. J equivalent to 9, O 14, J again 9, and U is 20. Therefore, J, O, J, U termed into numbers, that is 9, 14, 9, 20. Now ek of x is equal to ek of j, which is equal to ek of, instead of j we have 9, which is equal to 7x plus 3, that is 7 into 9 plus 3, which is equal to 63 plus 3, that is 66, mod 26, it will be 14. In a similar fashion, we can find ek of the next is O, ek of O, that is equal to ek of O is 14. On simplification, 7 into 14 plus 3, on simplification, we will get it as 23. ek of j, already we have, ek of j is ek of 9, that is equal to, we have 14. Then finally we have ek of u. ek of u is equal to ek of 20, that is equal to 7 into 20 plus 3, which is equal to, reduced to the form 13. Therefore, decrypted form of Joju, in numbers decrypted form is 14, ciphertext 14, then 23, again 14, last 13. Okay. It's by number alphabets O, X, O, N. Therefore, Joju is decrypted as OX, ON. Now, this decrypted one can be used by using this key. We can find the actual value now. We have go to Joju. For that, we will use dk of y is equal to y minus b into a inverse mod 26. അത് കാണാനായിട്ട് ആദ്യം കാണേണ്ടത് dk of O ആണ്. dk of O. dk of O means dk of 14. O is 14. By using this identity, we have inverse means 7 inverse. A is 7. Here A is 7 and B equal to 3. Therefore 7 inverse into 14 minus 3, that is equal to 7 inverse is 15 into 11, that is equal to 165, that is equal to 9. In a similar fashion, we can find dk of Ex equal to dk of 23. You can find it to be, yes, dk of 20, yeah, that is Ex, that is 23, which is equal to 14. Again, dk of O is equal to 9. Then finally, dk of 13. dk of 13 equal to, dk of 13 is equal to 20. Therefore, the numbers are 9, 14, again 9 and 20. You can check the alphabet. The 9 number shows J, 14 Z O, and 9 J, and 20 U. Therefore, again we got Joju. Okay, hence this is the example for the new cipher. We will start with the new cipher, Vigenère cipher. The Vigenère cipher. This Vigenère cipher is not a monoalphabetic cipher, because monoalphabetic cipher means we found shift cipher, shift and substitution ciphers, and these are all monoalphabetic ciphers, because all these two ciphers will give, we have നമുക്ക് കിട്ടുന്നത് കൃത്യമായിട്ട് ഒരു ആൽഫബറ്റിലേക്കാണ് അല്ലെങ്കിൽ നമ്പറിലേക്കാണ് അത് പിന്നെ ഡിക്രിപ്റ്റ് ചെയ്ത് പോവുക. അതുകൊണ്ട് അതിനെ മോണോ എന്ന് വിളിക്കും. പക്ഷെ ഈ വിജനർ സൈഫർ മോണോ ആയിരിക്കില്ല, കാരണം അതിന് ഒന്നിൽ കൂടുതൽ ഇമേജ് വരാം. നോട്ട് മോണോ ആൽഫബറ്റിക് സൈഫറാണ്. അപ്പം മോണോ ആൽഫബറ്റിക് സൈഫർ അല്ലാത്ത ഒരു സൈഫറാണ് എന്ത് വിജനർ സൈഫർ. വിജനർ സൈഫർ ഈസ് ആൻ എക്സാമ്പിൾ ഫോർ നോൺ മോണോ ആൽഫബറ്റിക് സൈഫർ. Now we have crypto system Vigenère cipher suggests that plain text equal to ciphertext equal to key space equal to Z26 cross Z26 cross m times. That is plain text, ciphertext and key space consisting of m copies of Z26 itself. Therefore, the key size is very large. Therefore, this Vigenère cipher will give us good results. അത് പൊളിക്കാനൊന്നും പറ്റില്ല പെട്ടെന്ന്. സെക്യൂരിറ്റി നന്നായിട്ടുണ്ടാവും. കാരണം Z26 ക്രോസ് Z26 എം കോപ്പീസ് ഉണ്ട്. അപ്പോൾ എം എടുക്കുന്നതനുസരിച്ചിട്ടിരിക്കും കെയുടെ സെലക്ഷൻ. അതുപോലെ തന്നെ പിയുടെയും സിയുടെ വി ആർ ഇൻട്രസ്റ്റഡ് ഓൺ ദ കീ സൈസ്. ദഫോ കെയുടെ സെലക്ഷൻ ഈ എം നമ്പർ കൂട്ടിയെടുത്താൽ നമുക്കറിയാം Z26 അത് ക്രോസ് എക്സെട്ര എം ടൈംസ് മീൻസ് ഇറ്റ് വിൽ കൺസിസ്റ്റ് ഓഫ് സോ മെനി keys. Key number is very large. Therefore, somewhat secured ആയിട്ടുള്ള ഒരു സൈഫറാണ് Vigenère cipher. Now, as an example, yes, here encryption function ek of x1, x2, etc., xm, because we are taking x1, x2, etc., xm is an element of zm cross zm, z26 cross etc. m times. Therefore, any element of this will be an m tuple. Therefore, ek of x means x is an m tuple, that is x1, x2, etc., xm. Ek of x is defined in this manner, that is x1 plus k1, x2 plus k2 plus etc. plus, comma etc., xm plus km, where k equal to, the key k is equal to k1, k2, etc., km. Therefore, this is our ekx. Just k യുടെ components x ന്റെ components തമ്മിൽ ആഡ് ചെയ്യുന്നതാണ് എൻക്രിപ്ഷൻ. ഡിക്രിപ്ഷൻ വരുമ്പോൾ നമുക്ക് തിരിച്ചു കിട്ടണമെങ്കിൽ നമുക്ക് സ്വാഭാവികമായിട്ട് പറയാം dk of y is equal to dk of y1, y2, etc., ym, because y is a member of Z26 power m. Therefore, that will be an m tuple, which is equal to subtracting the elements y1 minus k1, y2 minus k2, comma etc., ym minus km. Therefore, this is our dk of y, of y1, y2, etc., ym is equal to y1 minus k1, y2 minus k2, etc., ym minus km. Therefore, in Vigenère cipher, we will use p, z, k, all are the m multiple of family Z26 m copies, and ekx like this, dk of y this, then ek, dk combined together we will get the nullification effect, that is encryption will be decrypted. Now, as an example for Vigenère cipher, we'll take m. M is our choice, m equal to 6, and the keyword cipher. Keyword is cipher, and the corresponding number c is 2, I is 8, p is 15, h is 7, e is 4, r is 17. This is the number conversion of cipher. 2, 4, 6, 6 elements, and m is also 6, m equal to 6, that is, this is k1, k2, k3, k4, k5 and k6. Here it is k1, k2 up to km. M equal to 6 means k1, k2, k3 up to k6. Therefore, we will choose m as 6. Suppose the plain text is, നിങ്ങളുടെ ക്ലാസ്സിൽ തന്നെയുള്ള വർഗീസ് 2, 4, 6, 8 എണ്ണമായിട്ടുള്ളൂ. അപ്പോൾ അതുകൊണ്ട് 8, 8, 12 വരുവാണെങ്കിൽ നല്ലതായിരുന്നു. അപ്പോൾ എൻ്റെ പേരും കൂടി ചേർത്താലോ, JOJU. Totally we have 12 characters. Varghese Joju. കുഴപ്പമില്ലല്ലോ. Yes. Now convert it into numbers. V is കുറേ അകലെയുള്ള ആൽഫബറ്റ് ആണ്, അത് 21 ആണ്. A 0 ആണ്. R 17 ആണ്. പിന്നെ ഏതാ വരുന്നത്, G 6 ആണ്. H 7 ആണ്. G 4 ആണ്. H is V, A, R, G, H, E, S. As you know, S is 17, 7, 4, 18. Again, E varunu, that is 4, 9, 14, 9 and 20. These are the number version of Varghese Joju. Now, in order to find EKX, that is EK of this one, what we'll do is, we'll write down, that is the EKX, you know, component wise addition ആണ്. ഇവിടെ കാര്യം നോട്ട് ചെയ്യാനുള്ളത്, ഈ വർഗീസ് ജോജുവിൽ ആകെ 12 അക്ഷരങ്ങളുണ്ട്, പക്ഷെ കീ സൈസിൽ 6 ഉള്ളൂ. അപ്പോൾ ഇവിടെ നമ്മൾ എന്താ ചെയ്യാന്ന് വെച്ചാൽ, ഈ കീ സൈസ് ആദ്യം ഇവിടെ എഴുതും. 2, 8, 15, 7, 4, 7, 2, 4, 6. ഇത് തന്നെ ഒന്നുകൊണ്ട് റിപ്പീറ്റ് ചെയ്യും. 2, 8, 15, 7, 4, 7. ഇതാണ് കെ ഐസ് വരുന്നത് നമ്മുടെ. ദീസ് ആർ ഓൾ എക്സൈസ്. x1 plus k1 ചെയ്യുമ്പോൾ ഇത് വരും 23. 8 plus 0 plus 8, that is 8. 17 plus 15, 7, 32, 6 വരും. 13, 11, 11, 20, 12, 24, 21, 13, 27, 1. ഇങ്ങനെയാണ് അഡീഷനായിട്ട് വരിക. 27. Last one. After 4 we have 17, that is 17. Therefore 37, that is 11. Therefore after this operation we will get 23, 8, 6, 13, 11. This is 17, therefore it will be 14, 13, 11, 20, 21, sorry, 21. Then 20, 12, 24, 21, 13, 11. Therefore, this is our EK of x. That can be write it as x, then I, G, N, L, V, U, M, Y, V, N, L. This is our ciphertext. Joju, Varghese Joju becomes X, I, G, N, L, V, U, M, Y, V, N, Z. This is our ciphertext. Now go back to the plain text. For that, we have to subtract the key from this one. That is, keys are 2, 8, 15, 7, 4, 17, 2, 8, 15, 7, 4, 17. Subtract it from here. This is 21. 8 minus 8, that is 0. 6 minus 15, minus 9. 6 minus 15. 13 minus 6, that is 6. Then 7, 4, 18, 4, 9, 14 and 9, 14, 9 and minus 6. This will be the subtraction. Okay, this 21, 21 itself, 0, 0, minus 9 is nothing but minus 9, 26 avanite 17, 6, 7, 4, 18, 4, 9, 14, 9. Here minus 6, 26 avanite 20. As you know, this is nothing but 21. 0, 17, 6, 7, 4, 18, 4, 9, 9, 14, 9, 20. This is nothing but Varghese Joju. Therefore, Varghese Joju first encrypted as X, I, G, etc. Then again go to decrypted as Varghese Joju. Thank you.